This video's main goal is to provide a better understanding of how we can use downlinks to communicate certain steering responses to an orbit downhole. So throughout this video, we'll give a little bit of background of what goes on in the shop before the tool arrives on location, the different types of downlinks and rules associated with each, how to select your different timing sequences, actually executing a downlink, and then we'll end with some good practices to use in the field. So let's start with a basic understanding of the process each orbit undergoes in the shop. The control unit is programmed with a predetermined list of commands or steering options that is stored in the tool. This list depends on three things: the specific type of RSS, or in this case an orbit, what type of control unit is placed in the tool, and then the corresponding software for that control unit. Each tool specifics are documented on its OST or outgoing systems test and provided to the field via the SharePoint. When performing the job, the DD selects the appropriate steering option from the list, then communicates that command to the tool by varying between certain surface parameters between a high and low state. Each command has a specific timing sequence that the tool can identify downhole. There are two types of surface parameters the DD can use, either a flow or color RPM downlink. Before going into the rules between each, there's one more basic thing you need to understand, and that is the bit period. This is essentially how fast you want to send the downlink. Basically, you can tell the same story in a 5, 10, or 15-minute version. Obviously, the lower the bit period, the faster the downlink, and the quicker you can go back to drilling ahead. But it's good to note that the 36 and 60 second bit periods are there for troubleshooting purposes. So the longer the downlink, the easier it is for the tool to understand. So if you're having trouble communicating your 18 second, you can move to a 36 or even a 60 second downlink. So for each type of downlink, there's a specific set of rules. For instance, for the flow, when you're varying between your high and your low state, you need to change from 10 to 20% gallons per minute. So your high state maxes out with your max drill flow. This comes from your flow loop analysis on your OST. So you can see highlighted here, you want to use your mud corrected values. So maximum drilling flow rate is, for this OST, would be 326 gallons per minute. And then your low state cannot go below your minimum tool turn on flow rate. Next, you want to note that it can accept an 18, 36, or 60 second bit period. The 18 or 36 depends on what setting the tool is downhole. So you have to tell it, okay, I'm going to send an 18 or I'm going to send a 36 before it can accept those. The 60 second requires no predetermined setting. It can accept a 60 second bit period at any time. Also, the last thing to note for a flow downlink is you can send this in any section of the wellbore. So completely vertical, in the tangent, curve, lateral, doesn't matter. You can send a flow downlink. The second option is your collar RPM downlink. So you'll notice this one needs to drop between the high and low state by a minimum of 40 RPMs. So your max cannot go above 350 RPMs, and that's bit speed. So your surface RPM plus the speed of your motor as a function of the flow. And then the minimum can go all the way down to 0, but it is not recommended that you drill ahead with 0 on your rotary. Also, you want to notice that the 18 second bit period is not available for collar RPM downlinks. So your only two options are sending it in a 36 or a 60 second bit period. Unlike the flow, the 36 or 60 are always available. There's no predetermined setting you have to put the tool in to accept those color RPM downlinks. Lastly, you want to note that it's recommended to have at least 10 degrees of inclination in the hole. The tool has trouble depicting between the high and the low states with low angle. The last thing you need to understand is the 4 different tool modes available for the tool. So you have a manual tool face, inclination hold, hold inclination azimuth, or a power V option. The manual tool face is similar to a conventional motor. You can select to send it in magnetic or gravity tool face, and then you have a predetermined list of tool faces with associated steering ratios. So within that list, if you don't have the desired tool face or steering ratio you want, you can set one and then move it clockwise or counterclockwise by 12 degrees. Or you can have it steer harder with your steering ratio, plus or minus 10%. From your manual tool face, you can go to any of the other 3 tool modes. So if I want to engage in ink hold, I would have to recycle the pumps, take a survey, and my D&I package, which is roughly 8 feet behind the bit, needs to be at the survey point that I want to seek. After that, I would bring my pumps back up for at least 3 minutes above the minimum tool turn on flow, and then send my downlink to engage ink hold. At this point, it would lock into the last accepted survey by the power drive, and then seek that target. If my dip changed or my steering, if I wanted a new target, I can then nudge that plus or minus a half degree. I can also add some sort of steering ratio to the left or right in increments of 12.5%. Please note that the max you can bump left or right is 50% steering ratio. Similarly, if I was to put it into HIA mode, it would be the same setup. Require a recycle, lock into an inclination target, and this one has an additional azimuth target. So once you're locked into an azimuth target, you can nudge that one to the left or right by 2 degrees at a time. So last to note, if you're in ink hold or HIA mode and you want to go back to a manual tool face, it's automatically going to go back to a gravity tool face. And then your last option is the power V mode. So this is basically in gravity tool face 180 out. So it's going to seek vertical and go straight down. So now that we have a good understanding of the basics, we're ready to fill out our fast downlink timing sheet. This is basically the tool that we use to set up for the power drive that we have to back out our downlink timing sequence. You can find this on InTouch with the ID of 6452783. So the name of the game here is fill out your green boxes and you will get your desired timing sequence. To fill out our first 2, we'll need our OST. If you scroll to the tool configuration report, tool information section, you will find the tool type. So we know that our tool is in orbit, but we need to pick between PDCU GA and CA. These are 2 different control units. From our OST, we can see that we have a GA, so I'll select that. The next is our downhole software version. So 2 rows from the tool name is the tool firmware version, 30B. So depending on these 2 selections will change the timings and the options for what our commands are. So critical that we get these correct. Next is your tool mode. As mentioned previously, there's 4 different options. Manual, ink hold, HIA, and power V. So one thing to note here is this tool mode is selecting what the tool downhole is currently set in before we send the downlink. So we're going to assume right now we're in manual tool face. And then simply pick what downlink type you'd like to send. We're going to send a flow downlink. Okay, so now you'll notice we have all of our different predetermined steering options, and then they're depicted by the precursor and command. So say we want to send a tool face of 18 degrees with a steering ratio of 100%. We can go here and see the precursor and command is 1-6. So we'll go to our number 5, precursor 1, command 6, and then you see here it'll confirm what we're about to send. So 18 degrees, steering ratio of 100. Then we'll pick our bit period. So the tool's already got to be set in either 18 or 36. So whatever the tool downhole is set in, that's what we need to send. So we're going to assume we're setting in an 18 bit period downhole. Has the power drive tool been powered up for more than 3 minutes? Answer yes or no. And that's it. So now we have a specific timing between high and low states for this command. So you always want to start in your nominal high state. And then as your timer hits, you will go to your low state. So for instance, we'll start this downlink, 54 seconds. We'll go to low. Once our timer hits 1 minute and 3 seconds, we'll switch it back to high, and so on. Once you've sent the downlink and you have real-time comms, you can use number 6 here to confirm the downlink has been accepted. So the D point here is PD steer, and you have to know if the tool is in magnetic or gravity tool face. Depending on what setting it is, this is basically confirmation, thumbs up, this is the downlink that you sent. The second option you have for selecting your timing sequence is an app provided by Schlumberger called PowerDrive RSS. And you'll notice it is the black and blue icon seen here. This app is available for iOS or Android devices. Once you open it up, you can hit this blue button at the top, select RSS tool. You have your 3 tools to choose from, X6, Archer, and Orbit. Each tool has its 2 corresponding control units to choose from. So again, you get the type of control unit in your tool from the OST. For this example, our OST said we had a PDCU GA, so the very bottom left option. Software version, also from the OST, is 30B. And the rest of it is set up just like the spreadsheet. You have your 4 tool modes. We'll select manual tool face, your 2 downlink options. You'll notice when I select RPM, the 18-second bit period option is deactivated. This is because you can't send an 18-second bit period color RPM downlink, but you can send a flow downlink, and that's what we'll do for this example. Last is, has this tool been powered up for 3+ minutes? We're going to say yes to that. And then you have your different command options. So the first page on the manual tool face is basically editing a command you're already executing downhole. So you can change your steering ratio, tool face. You have the commands to engage inclination hold or HIA. Change it between your different bit periods, gravity or magnetic mode, and so on. The other option up here is to choose a tool face and steering ratio from the predetermined list. So we will select command 1-6, tool face 18, steering ratio 100%. So the last screen before we start our timer, we have the option to enter high and low flow rates. Okay, this is something that the spreadsheet doesn't offer. So basically our high state flow for this example will be 300 gallons per minute. Then we can have the app calculate what our percentage drop will be. So if we select 20%, it will calculate that our low state will be 240 gallons per minute. The last little reminder here is put your device in airplane mode. So this is a good idea before you send any downlink so that you don't get a notification, phone call, etc. and disrupt your downlink. Okay, so now we're completely set up and ready to start our timer. So we're in airplane mode. Our driller is ready to give us his attention for the next 5 minutes, and we are at our high state flow. So we're at 300 gallons per minute. We'll go ahead and hit start timer, get a 3-second countdown followed by another minute-long countdown. Between both of these, we're still going to be at our high state flow. We're consistently flowing 300 gallons per minute, and we'll stay at that until this orange circle gets to 0. At that point, we will swip down to the next reduce low flow to 240 gallons per minute. And then we'll go back and forth until our sequence is complete. As we wait for this to time out, we'll look at the rest of the setup. You have a progress bar at the top that tells you exactly how many minutes and seconds you have left on the downlink. You have a confirmation of what downlink you're sending up there. So at this point you realize you're sending the wrong one. You can hit this stop icon at the bottom left, hit stop timer. If you fat finger it, you can just hit continue and it'll continue without skipping a beat. And then we'll get 3 short beeps followed by a long tone. That long tone signals us to reduce our strokes to our low state. So now we're at 240 gallons per minute. Okay, so for the sake of this video, we'll skip to the end. You'll see once we finish our last high state, it'll say sequence complete, give us a green check mark. We have the option to put our depth that we sent the downlink in. And at the bottom it says if you're using real-time D points, confirm the downlink has been accepted. So these two numbers correspond to whether the tool was in magnetic or gravity tool face. For example, if it was in gravity tool face, it would send up a PD steer value of 166. So when we receive that, that's basically the tool giving us a thumbs up that the correct downlink was accepted. So a couple more things. If you notice at the top of the screen, there's a required wait time until next downlink. So say you want to double up and send consecutive downlinks, it has an automatic timer of how long you have to wait until you initiate your next downlink. Lastly, if you go all the way to the home screen, you can see recent downlinks down there. There's a depth of 12,500, the command and downlink that we just sent. It's got the date and time, so you can keep track of all your downlinks. If you click on recent downlinks and click this little blue square with an arrow pointing up at the top right of your screen, you have the option to email your downlink tracking sheet to yourself. That way, at each handover, you can compile and have the complete downlink tracking sheets for the run. So to wrap this video up, we will end with some good practices to use in the field when performing the job. So number one, when you go to execute your downlink, you can do it while drilling on bottom. Just take whatever your on bottom ROP is, cut that in half, and control your auto digger with 50% of that ROP. Don't limit the weight on bit, don't limit torque, just limit ROP so that you're controlled digging. And that'll be your 3-minute quiet time before you start your downlink. Also good practice is if it's your first time working with the driller or the rig crew, before you initiate the downlink, to let them know if someone's safety or equipment is going to be damaged if you continue with the downlink. That it's no problem, abandon it and do what you got to do. We can get the downlink later. On the same note, if it's something not crazy and we're mid downlink, maybe don't answer the rig phone or ask your crew not to bug us for another 2 or 3 minutes. Okay, the next thing is the process of engaging ink hold or hold ink as. Basically, you'll be in either magnetic or gravity tool face, and you have a certain inclination or azimuth survey station that you want to lock in as your target. So while your pumps are on, you will pull back to the survey station that you want, and you want your D&I package of your power drive to be there, which is roughly 8 feet behind the bit. So with your pumps on, pull back to that survey spot, drop your pumps for at least 2 minutes, then pick them back up and flow on it for 3 minutes or more. So what that's doing is the tool is taking a survey at that spot, and then your pumps up 3 minutes will lock that survey in. Then you can start your downlink to engage either ink hold or HIA. Another common question is if you're going from magnetic to gravity or vice versa, whenever you send that initial downlink to switch, it will keep your tool face. So it is not recommended to drill ahead while sending that, because depending on your orientation, it could steer the direct opposite way that you desire. So just knock your ROP back to like 2 foot an hour. That way you're not making any hole. Change it from whatever tool face you want, and then send your desired tool face. Another common question is if you're disengaging HIA or ink hold, do you have to put it in gravity tool face? The answer is no. You can go straight to a manual tool face setting, and it will be in gravity after that. Also, you can go from magnetic or gravity straight into HIA. You don't have to go to gravity and then HIA mode. Another tactic to execute is a path of least downlinks. Sometimes when you're using your manual settings, there's 10 different ways to get to the same setting. So you want to put some thought process into, okay, I want this steering ratio, but I don't want this tool face. How can I use these 12-degree increments or my plus or minus steering ratio to quickly get to where I need to be? And lastly, always confirm your initial settings with your OST. Never assume it is set to the default or whatever it was last job. So you want to know what bit period you're set in, if you're magnetic or gravity tool face, if you're in neutral or power V setting. All these things come into play and can save you some time on the rig.